Welcome back. So, this was the last slide we were discussing about the lithospheric plates, uh, and I also explained about that there are continents on the surface, and then you have uh, those continents are covered by oceans and sea. Okay, but those oceans are basically, of course, the water is on the top, but those are also been termed as the plates. Okay, so there are multiple plates which are available. More than dozen plates are available on, or they exist on this planet, and they have moved from its original place, which all plates were located in the southern hemisphere, and then they moved. That part we will talk in plate tectonics. But right now, the important point is about the earthquakes, what we are talking about, and how they are aligned and oriented along this plate boundaries. The plate boundaries basically we are talking about where the two plates are either coming closer to one another, or they are colliding, or they are subducting. So, that part or those important aspects we will be discussing in the plate tectonics. Okay. So, I can just explain little here, but little bit, but we can have more discussion. Like when I'm saying that the plates are coming closer to one another, so they collide, they subduct, or they pass each other. Okay. So, this is the combinations which are available on this planet between different plates, and they are producing the strain, or you can say the stress has been building up there, and there when that uh, the energy which has been stored is released, that results into your earthquakes. Okay. So, this red lines which are been marked, they are showing the plate boundaries. So, let us move ahead and see that how so basically the earthquakes are been triggered along this plate boundaries and away from the plate boundaries. That is what we call within the plate and along the plate boundaries. So, for example, you also see earthquakes which are occurring here. Okay, this area. So, those are within the plate. Okay. Now, if you look at this again, that what we have been discussing about, that you have the topography which has been built up, but now coming to the part of that, how often do earthquakes occur around the globe? Okay. So, as we discussed about that, recently we had Myanmar earthquake, and that was 7.7 magnitude. But how often the earthquakes are occurring? Right now, what we are recording this lecture, earthquake might have occurred somewhere in this world. Okay. So, Earth comprises several active tectonic boundaries. That what we were talking in the previous slide, between active tectonic plates. Hence, the earthquake always keep occurring somewhere on the earth. Okay. So, as I told that right now we are having this recording, this earthquake might be happening somewhere in on this globe. Okay. So, the National Earthquake Information Center (NICE) locates about 12,000 to 14,000 earthquake of different magnitudes. Okay. Now, what are these magnitudes? What are the implications of the energy which has been released during this magnitude? That also we will talk later on when we are talking about the interior of Earth, and then we will discuss about the different energy levels which are been released during individual or respective earthquakes. So, different magnitude earthquakes are recorded each year, almost like 14,000 number of earthquakes have been recorded. Now, on an average, if you take less than 2 magnitude earthquake, which we should not be very much concerned about, because these magnitudes are not going to create any damage. Okay. For the less than 2 magnitude, it will be barely noticeable by even the experienced person. Okay. So, this is not this earthquakes are not important, but the earthquake, this what we call the micro earthquakes. Now, these micro earthquakes are important for the people or the group of research groups who are using this to understand the pattern of the earthquake occurrence, at what depth these earthquakes are occurring, even moderate magnitude earthquakes and large magnitude earthquakes, but they keep eye on this type of micro earthquakes. Okay. Now, this earthquakes less than 2 magnitude earthquake, they occur several hundred times a day worldwide. Okay. So, the energy is getting released, okay, but the amount of energy which is released in 1 magnitude and then just you shift to the 2 magnitude, it is much higher. Okay, which is in almost like multiplication factor of 32 or so. So, the energy amount of energy which has been released, we say sometime very in news channels we heard that we hear that okay, the magnitude of 7.5 or somebody will say 8 magnitude. So, there is lot of difference between the 8 magnitude earthquake and 7 magnitude earthquake. Now, coming to the large magnitude earthquakes or major earthquakes, magnitude greater than 7 occurs more than once per month, and these are damaging earthquakes. Okay. So, this what we are talking about, these are damaging earthquakes. So, on this planet, this magnitude earthquake which is greater than 7 occurs once a month. So, every month you are having this earthquakes. Okay. In some places you have like they are damaging, but in some areas they are not, because it depends on the population exposed to such type of hazards. Okay. So, if they are the area is populated, even 6 magnitude earthquake will be dangerous, even the 5.5 magnitude earthquakes will result into some damage. So, major earthquakes greater than 7 magnitude occur more than once per month. So, this is one, and the great earthquakes. Okay. So, we categorize great earthquakes greater than 8 or equal to 8 magnitude. Okay. Nevertheless, we have also we were talking about that on this planet the largest recorded earthquake is 1960 Chilean earthquake, that was 9.5. So, even this 8 magnitude and 9 magnitude, there is like lot of difference between the term in terms of the energy. So, this occurs once a year. So, it is every year we are going to have greater than 8 magnitude earthquake anywhere in the world. Okay. It is not in the same place you will get this earthquake, but we have the plate boundaries as you have seen in the previous slide. So, they are all like sort of a network over this planet. So, these are the earthquakes which are damaging, that is your 7 magnitude earthquake and greater than 8 magnitude earthquake, and this falls under the category of what we call the major earthquakes and the great earthquakes. So, Himalaya, what we have, and the Andaman Nicobar are capable of triggering your great earthquakes, whereas Kutch, Gujarat is capable of triggering major earthquakes. Okay. So, we have like 3 sides where we are like cordoned with this type of hazard. Now, there is again like the occurrence of earthquakes at different location. So, if you look at this, these are the plate boundaries which we are talking about. Okay. If you look at this, then it shows that how many earthquakes are occurring, and they are very much aligned. Okay. They are very much aligned, preferredly oriented along the plate boundaries. I will play it again and then you can realize that yes, they are occurring. So, in some areas you have like large magnitude earthquakes, you have moderate magnitude earthquakes, you have micro earthquakes which are going on. Okay. So, even in the ocean, what you see here, these are the on the oceanic plate we are having the spreading centers and all that. Okay. So, these are the areas where the plates are moving away. This part, as I have been repeatedly telling, that we will discuss in the plate tectonics, but you can see in this area where we are having. Okay. And this area is the Pacific ocean area. So, we have multiple earthquakes which are occurring here, and then you come down to this is Japan here, and then you are having this Sumatra uh, Andaman region, okay, and then goes to Himalaya. So, this regions are pretty active regions where you keep on getting the major earthquakes, and as we have discussed in the previous slides, at less than 2 magnitude, you will keep having every day, or many earthquakes might be triggering every day, 7 magnitude once in a month, and 8 greater than 8 magnitude once a year. So this is the scenario around us on this planet. Okay. So the best way to minimize, as let me be very clear, and it may be noted that we are trying to minimize the hazard posed by earthquakes, and understand that what are the signatures, how we can know that what was the sequence of the past earthquakes, what is the history of the past earthquake, but we cannot stop it. Okay. Because this plate movement is not governed externally, it is an internal process. Okay. That we cannot do. So active tectonics, basically in earth sciences, the term tectonic is referred to, one, the processes, that is earth processes, okay, geological processes we are talking about, structures, geological structures, we are not talking about the civil structures here. So geological structures are like folds, faults, joints, and in civil engineering we will call this as a discontinuities. Okay. So as I mentioned in the last lecture also, that if you are having horizontally stratified or horizontal layers, when they are folded or crumpled, okay, then how it looks like, that is your folding. Okay. So for example, you are having this and you are folding this. Okay. So this fold is your geological structures. Now if there is a fracture or the crack in a simpler way, okay, if we talk about, and there is a displacement, then we term that as a fault. So these are the discontinuities which we see. Okay. And the landforms which are associated with the deformation on the earth crust, that also we take into consideration. So tectonic refers to the evolution of the structures, that is geological structures, and landforms over the time, over a time span. Okay. So it takes thousands of years, millions of years to develop. Okay. But some processes which are on the small scale can be instantaneous. Okay. So for example, if you compare Himalaya, Himalaya is the product of the collision of two plates. Okay, or subduction. Initially it started and then collided. So overall the tectonics has played part. So this process has taken place, like taking place since long. Okay. So the collision first, which has been identified based on the ages and all that, or the sediment types and all that, it says that it started at 50 million years back. Okay. So that is the process. Okay. So that is how we are looking at the height of Himalayas, which is more than 8,000 meters. Okay. And at instantaneous scale also we see, and those are been produced, those landforms are been produced by earthquake. Okay. So further, if we look at on the global scale, okay, on a global scale, we are concerned with the origin of continents and ocean basins. Okay. So this we are looking on a very large scale. Okay. And which are the largest landform produced by tectonics on Earth. Okay. So this is tectonic deformation. So what we are looking at, the continents right now, they are also they produced because by the process of tectonic movements. Okay, on the Earth. Then coming to the regional scale, we are talking about that we are interested in the structures they are produced as like mountain chains. Okay. So we talk about the Himalayas. So here in the larger global scale, you take, if you want to say, like let us take Indian example. Okay. So Indian subcontinent on a global scale is a plate. Okay. And regional scale, if you come, you will talk about the Himalayas. Okay. So we are interested also, the active tectonics also helps us in understanding that what are the processes which have happened in the past and which caused the formation of this landforms on global and regional scale. Okay. Further, if you move, then we are coming to the local scale. Okay. So from global to regional to local. Now local, how you will see these features or the landforms. Okay. Then we often study the features like small folds, okay, which may form elongated low hills or faulting. Okay. So faulting is basically where you are talking about the discontinuities. So small folding. So let me just put here like if you are having the layers which are deposited, either it is sediments or rocks, and then when they are subjected to the stress, okay, or the forces, then what you are going to see is the fold, okay. And you can do this taking your um, loose bound notebook or a book, and then you try to apply the force, okay. Then you will see that it gets folded. So this folding is been seen at the local scale, okay. So if you look at Himalayan topography, then starting from the southern side, it rises up, okay. It goes up. So this is your Indo-Gangetic plain, and then if you go up, then we say this as an sub-Himalaya, then this is lesser Himalaya, and this is higher Himalayas. So this is mountain chains. It is Himalaya is not a single mountain. It comprises of multiple mountain chains. Okay. And this chains or the mountain chains have developed over the time. It is not instantaneous in one go. It took long span of time to develop on this planet. Okay. Now coming to this the other part, what we try to learn and try we are interested in by learning the active tectonic part, that this folding or faulting which may result into surface ruptures. Okay. Now this rupture word is very commonly we use. Okay. So rupture is the fracturing of the material or the crust. Okay. So this rupture, if it reaches to the surface, then we say this is a surface rupture, and this surface ruptures are important for us because we are going to identify and learn how to identify this paleo or ancient surface ruptures which produced large magnitude earthquakes, great magnitude earthquakes in Himalaya as well as in Andaman Nicobar area or the Kutch region. Okay. Andaman Nicobar is like we have the oceanic plate, and most of the deformation is been taking place in the subduction zone area. Okay. But some faults or the fractures, weak zones are also available on the Andaman Islands. Okay. They may produce in future, they have produced in the past, and they may produce earthquakes in future also, and which are associated with the surface rupture. So, uh, if we just look at the local scale, we often study the features such as small folds which may form elongated hills or faulting which may result into surface faulting. Okay. And production of relatively small, okay, this folds or the structures may be relatively small as like in time of in terms of the in few a few seconds to hundreds of meters. Okay, it can be very long or very small also. Okay, so this again an important part which we never miss out. Okay, when we try to study the landforms, we try to look at that even a small scale feature on the surface, undulation on the surface, should not be taken lightly. Okay. It may be a indicative of any uh, past earthquakes. Okay. So, a few tens or hundreds of meters long by less than 1 meter to about 8-meter high. Okay. So, this is just an example which has been given that these are the like features which may be like small like this, okay, or maybe it will be quite high or it may go up also. Okay. So, you should not even miss this features. Okay, and they are of like less than a meter also. Okay. And this type of landforms which are formed like produced in terms of the surface rupture, then this type of landforms we term this as an fault scarps. Okay. So earlier this surface was like smooth, and then we are having this was the surface, but later after the deformation this has formed something like this. Okay. So this have been termed as like your fault scarps. Okay. So, what basically we are doing, we are coming from the regional or the global to regional, and then we are trying to understand the local scenario. What is the deformation pattern and all that? Okay. So, we will learn about the fault scarps, how it looks, how to identify the fault scarps, what are the different type of landform features which helps us in identifying this active faults and active tectonic features. We will learn that part. Okay. Now, the impact of the earthquake, if you look at, okay, then basically where this information plays an important role, why we want to study the nature of the past earthquakes, why we want to do this type of studies, why it is important, why, what is the implication, what are the societal implications for this. Okay, the reason is that earthquakes never kill the people, okay, but buildings do. So, occurrence of the earthquake, the location of the earthquakes as ruptures, if we identify, we will minimize this part. Okay, that is the damage. Most of the earthquakes and around the globe, if you look at, okay, and try to go back and understand, they have the people were killed, okay, because of the building collapse and not because from the surface ruptures. Okay. So, this is an example of 1994 uh, Los Angeles earthquake, where again the poor construction. Okay. I am not going to go into the detail of the structural aspect, structural engineering aspect of this, but yes, of course, these are the reasons, and few maybe slightly we will touch when we are talking about the seismic shaking and all that. Okay. This is another one, 1985 Mexican earthquake. Then this was 1995 Kobe earthquake. Then this was 1999 Chichi earthquake. So, try to look at what I'm trying to show here is that one is the damage, and then second part is the surface rupture. So, this is your surface rupture. Okay. So, this is your surface rupture here, which was because of the 1995 Kobe earthquake. So, this portion of the has moved up. Okay, and also there was a movement which occurred like this. Okay. So, we will come to this, that how this type of movements takes place, and what are the landforms which are associated with it. One thing what they have done, I have a separate lecture on this, but I'll just briefly mention here that uh, after this 1995 Kobe earthquake, the Japanese uh, people and the government, they decided to preserve this surface rupture. So, this is what we are having, we call as an surface rupture. And this portion, if you see from here, which I was trying to show you sketching in the previous one. Okay, so this goes like this, if I put, and this is termed as your fault scarp. And the displacement which you see here is along this one, and this what we call is a fault plane. So, the idea is that if you know such surface ruptures, topography of the surface rupture on ground, okay, and you have mapped and you have produced a very detailed fault line maps or the illustrations which can be used by the developers, the urban planners and all that. Okay, the local people, they should know about that. No one should be allowed to put any structure on this. Okay, no structure should be built on this. The reason is because next earthquake this will move and you will have this, any buildings or any civil structure which has been constructed will be damaged. Okay. The photograph which you are seeing here is not that because of that it has been built on fault, but this was because of the ground shaking. Okay. Let us see few more photographs here. So, this is a topography again which has been developed. So, if you take the profile here, then it comes like this. Okay. So, it goes like this. Okay. So, this is your what we call we were calling as in you are having the fault scarp. Okay. And this was in 1999 Chichi earthquake. So, without having proper data and understanding this uh, this running track, and there is this was in stadium. Okay, this running track was been developed or the constructed across the fault. So, when there was a movement along this portion raised up. Okay, so this has moved up, and you can see that it is you clearly see based on the person standing here that this is much more than around 2 meters height. Okay, so and the dam or was constructed across the fault without having proper understanding what was damaged. Okay, then this was in Bhuj 2001. Again, we had a very poor understanding about this, and this was in 2004 tsunami. Okay, Andaman tsunami, the damage pattern and all that. Okay, so this was transoceanic tsunami which killed almost like 3 lakh people, and it affected around 14 countries which were joining the Indian Ocean and other portion. Okay, so I'll stop here and we'll continue in the next lecture. Thank you so much.